Hey kiddos, today we're going to talk about scientific notation. Now what scientific notation is for is that we have to have some way to sort of condense down an abnormally large or really small decimal number. So for instance, this number is one of the most important numbers in all of chemistry. It's Avogadro's number. This is how many particles are in a mole of something. That doesn't mean anything at all to you now, but it will in a few weeks or a month or whatever. So this number is really important. Now, in a lot of calculators, you wouldn't even be able to put this number in as it is because there's not 20-something digits worth of number space to type in the numbers. So we need some way to express large numbers, and we'll see here in a second, really small numbers, in a way that will make a little bit more sense. And so that's what we're going to do in this video, show you how to put things into scientific notation and what scientific notation means. And then in our next video, we'll talk about how to do calculations with it. All right, so rule number one for putting a number, a big number or a small number, we'll see here in a minute, into scientific notation is that we need the decimal to be moved so that we only have one non-zero digit left of the decimal place. If you have any more than one non-zero digit left of the decimal, then that means that you're not in scientific notation. So you're going to have to do something to put everything back into scientific notation. So what that means is that we have a decimal place here, right? Okay, that's the unspoken decimal. We know it's there. And we need to move it until it's here. So that's rule number one. I'm not going to do that just yet because I want you to see what rule number two is first, and then we'll put everything into the correct setup. Okay, so rule number two says that my exponent is going to be the number of spaces that we move the decimal. And you might be saying to yourself, what do you mean by exponent? Okay, so every scientific notation number has the same general form. So there's a times 10 raised to some exponential power. And the exponential power is what rule 2 applies to. However many spaces I move the decimal, that's going to become my exponent. Okay, so that's the exponential part of it. The other part of the number is called the coefficient, and that's essentially whatever's left after you collapse the number back down. That how much you leave might be dependent on significant figures, or like in the case that we're going to do here, it might be just dependent on, hey, we're going to cut it off here and everything else was zeros and therefore placeholders, and so I'm not as worried about those. Okay, so let's go ahead and do this then, and then put this number into scientific notation. So we're going to count our spaces. We've got, this is where the decimal is. And I'm going to probably speed up the counting a little bit because it's boring to watch me do it. So, okay, so that took us 23 spaces. I'm going to write that down just so that I don't forget it. Okay, so what that means is that when I'm going to put my stuff in scientific notation, I automatically know that my exponent is 23. Now, it could be a negative or a positive. And so there's a couple of ways to remember. Essentially, if you move the decimal place to the left, you're going to have a positive number. If you move the decimal place to the right to obey rule 1, then that gives you a negative exponent. I always find that really hard to remember. I don't know why. I mean, I probably learned this stuff 30-something years ago. So what always makes more sense in my brain to remember is that if it's a big number like this is, then that's a positive exponent. So for a really small number like the next one I'll show you, then that's a negative exponent. Okay, so that takes care of the exponential part of the exponential or scientific notation. So what about the rest of it? Well, in this case, I don't really know anything about my sig figs, so I'm just going to take the non-zero digits there, and I'm going to count that. So 6.023 times 10 to the 23rd, and that's what you're going to use for Avogadro's number in a wide variety of calculations. All right, so we worked a really big number. What do we do with a small number? Well, the same rules apply. I'm going to want one non-zero to the left of the decimal. So that means my decimal's here now, and I'm going to want it to be right here. Okay, so I've got to move and count that many spaces. The number of spaces that I count, that's what's going to be my exponent. And then since I've got a small number, and since I'm moving the decimal to the right this time, my exponent is going to be negative instead of the positive that we had before. So real quick, just so that I don't forget anything in the process of doing it, I'm going to go ahead and write down my times 10. I can already sort of tell what my coefficient is, but I'm just going to wait until I count, and then we'll walk through that once we get there. So let's count the numbers. Now, I sort of divided this out where your commas would be, so that's going to make it a little bit easier. But again, I'm going to go ahead and count them, so it'll be sped up a little. Okay, so we had 34, and so my exponent here is going to be negative 34. I moved 34 spaces. I moved the decimal to the right, so therefore it's a negative. Also remember it's a small number, so it's going to be a negative. And then we're going to write down what is left. Remember that my new decimal is right here. Okay, so that becomes 6 point, actually I wrote that number down wrong. That should be 6.626. Sorry guys. And that would be Planck's constant, which is another really famous number that we'll use when we're doing some wavelength calculations, some energy calculations later on in the year. Sorry for the mess up of the numbers, but that doesn't change anything about the scientific notation part of it. So that's how we do that. I'm going to work a couple of real quick examples of how to put just normal numbers into scientific notation and how to take a couple of numbers out of scientific notation and expand them back out, just to make sure that you're clear on that. And then in the next video, we'll talk about how to do the calculation part of it. Okay, so some real quick examples just to make sure that we're all on board and can do this. So decimal point is here, 1, 2, 3, 4 spaces. So that's going to give me times 10 to the 4th. And then I've got 2.24 times 10 to the 4th. Okay, pretty straightforward. In this case, and remember I moved to the left, in this case I'm going to move to the right. 1, 2, 3, 4, 5. Remember I have to get this number to the left of the decimal, so that means I'm left with 6.3. I moved it 5 spaces, and I moved it to the right, which means it's got a negative in front of it. Okay? So how about these? These are already in scientific notation, so then what do I do with them then? Typically speaking, what you would be asked to do is probably to expand them back out into normal notation, in other words, without the times 10. So how does that work? Well, here it's pretty straightforward. You go the opposite way that you did to put it into scientific notation. If I put it into scientific notation this way, then to undo it, I go back the other way. So what that means is if I go left to get a positive exponent, then when I'm expanding a positive exponent, I take the decimal and go back right. And so that's exactly what we're going to do here. I'm going to go 1, 2, 3 spaces right. So that would give me 9, 2, 9. And then you're like, well, there was nothing there. What do I do? Well, any empty spaces there, you fill in with a 0. Okay? And how do you know that you got the right answer? Well, check it. Put it back in scientific notation. Make sure you got the same number. If I move the decimal here, 1, 2, 3 spaces to the right, I get 9.29 times 10 to the 3rd. That's exactly what I should get. So for the last one, again, you go the opposite direction. If I go to the right to get a negative number, then I go back to the left when I have a negative number and I'm trying to expand it out. So in that case, that means I'm going to go 1, 2, 3, 4 spaces. Okay? Again, what do I do with those empty spots? Well, you're going to fill those in with zeros. Okay? And I'm going to clean that up so you can actually see it. 0.000178 would be my correct answer. Now, typically speaking, you would sort of put that other 0 there just to let you know that the decimal is there. That's not absolutely necessary, and I certainly wouldn't mark you wrong for that, and that 0 does not count as one of your spaces, remember. You're counting the spaces to get to the correct decimal. All right, guys, next video we will talk about how do we do calculations with scientific notation, although I'll tell you the secret right now, most of the time you're just going to put them in your calculator and let it do all the work. But you should still know how to do it because there are some occasions when you won't have it. Thanks, kiddos.